We will be starting shortly. Hello and welcome to Microcontrollers with kingernorth. We are back here for another episode. This is episode 17. Today I'm going to be going over TFT and e-ink displays with CircuitPython and Arduino. So this is an interesting topic, and let's have a look at what we're going to be using today. So right here I have a number of displays going. Now I gotta say I have a little bit of light shining on here, so it may not be easy to see. We'll adjust the light as we go when we get into more detail. But looking at it right now, I see 6 different displays, and they're all displaying different things on the screens. And we actually have a combination. This is an Arduino over here with a screen on it. Then we have different CircuitPython boards, all with different screens on them. They're similar, but they're not all identical. And then we have this one over here, and this is a very unique one. This is called e-ink. And I'm going to be talking about that with some detail, because that's actually an interesting little product, and it makes it quite interesting because it's very unique compared to the other screens at all. So let's get going on here, and we're going to start with the Arduino, and we're going to take a little bit more time because I'm going to review the CircuitPython versions, including the e-ink and the different TFTs, and what I have running on there. And we're going to let those run, but we're going to describe those. But I'm going to take the first half of the show to build this Arduino program. So let me just do that right now. Let me move some of these out of the way here. And we're going to bring this one more to the middle. I'm thinking it's going to be okay, and I think we're going to try and zoom in a bit. We'll see if that helps with today. So let me get in here, and we'll line that up. And we can have a good look at the display itself. So there it is there. So this particular display, let me point out some of the features on here. So this is a very nice one. This one actually sits on top of an Arduino Uno. If you notice, it's the same shape as what our Uno normally is. So this one actually mimics that, and it's a direct plug-in. In fact, all these solder joints here and on this side line up with the existing pin or boards that are standoffs that are underneath. We have a bunch of extended sockets on the Uno, usually by default. And these just plug directly into those. So I had to solder these headers on. This is a shield. There are different shields made. This particular one is made by Adafruit. There's their logo up there in the corner, the little Adafruit logo. But we have a number of features on here. So what I have is here, first of all, I have a screen display. This is an older unit, so this is not really high resolution. And I'll talk about that when we get into the program. But we actually have the ability to display different colors, which is one of the advantages of TFT. And we're actually able to show a number of digits and letters and things like that on here. We also have this joystick style controller, which actually moves left, right, up, and down, and also has a button in the middle. So that's actually 5 buttons inside of that one round circle. That's connected through the I2C, so it's reading internally. And then we also have buttons A, B, and C down here, or I've labeled them on the screen as 1, 2, and 3, but we get that, and we'll see how we change that. We'll make them A, B, and C when we're done here. So anyway, so we can actually put those buttons in there and use those. This other button up here in the corner is a reset. Since we've covered up the button on the Uno itself, we now have access to an external reset button if for some reason we had to reset this. And if we reset this, it'll go through and it'll reboot. There's the screen. It comes up in a color. It changes colors a few times, and then it says press all the buttons. And if I go around here right now, this is what I have preloaded in here. I'm actually moving that stick. And finally, I'm going to push it down, which is the select button on there. We can see that the screen can change. And then we have a number of sizes of fonts that we can do with this. And they keep getting bigger and bigger and bigger. And you can see it's a boxy style numbers or letters. But the thing is we can change the size of it. So this is a graphics screen. Low resolution, but it's still graphics. So let's have a look at our program. Let's get into our main. So here we are in our main. Let's have a look at the Arduino. As usual, we're going to start out with an empty sketch. So we have an empty sketch here. Now I am going to cheat a little bit today. First of all, I do want to name this, just like I do every week. So let's go up here and go File, Save As. And we're going to create this file here. We don't want it in the Arduino folder. We want to put this in the show folder. So my electronic shows, and we're going to go down here all the way down to 17. And what I'm going to do down here is I'm going to create a new file, and this is called TFT test. And that's all this is going to be. So this is just a TFT test, nothing more than that. And I'm going to hit save. So I've done that. So now I have my new sketch started here with TFT test. Now I'm going to be copying and pasting a lot out of the program that you just saw as a demo because it's going to save me a lot of time. My normal thing here at the top, what I would throw in here, let me just bring down a few lines. I would throw in here some sort of title, and this would be TFT test by kingernorth. Now I will tell you that some of this code, I looked it up just like you should. I used an example file that was on there for the driver for this particular board, and that's one of the things you're going to have to do. Is you're going to have to go into your libraries and you're going to have to add these helper files. So let's have a look at what helper files are needed in here. I'm going to copy and paste it in because it's a longer list than normal. In order to get this to work properly, this is what we need. So these are our helper files. So first of all, there's the SPI. Now SPI is a communication format similar to I2C that we talked about in a previous show. I2C is a 2-wire communication. This actually uses 3 wires, of course, plus ground and power for that. The SPI is what's talking to the screen itself. So that's what the screen is connected to. So it's pre-using some of the pins that are out here for this, and it's allowing us to set that up. There is an SD card on here, so if you want to add more graphics, something that the Arduino Uno does not have is a lot of memory. So you may not have the ability to include bitmap files and save them. Well, you can put them onto an SD card, put them in here, and then call them up and buffer them and then display them. So including SDH will allow you to access the SD card. The graphics, the Adafruit graphics GFX file, that's going to allow you to put graphics on the screen. So you're going to need that if you're going to want to put bitmaps up. I'm not doing that today, but that would be what we would normally use. The last part here, the next parts here is the ST7735. That's the driver for this board that drives this actual TFT screen. That's the bigger chip up here is actually the driver chip. And that is an ST7735. I know that from looking it up on the Arduino, on the Adafruit site when I ordered the board. So you always want to do that kind of thing so you know what you're looking at. Seesaw is the I2C proportion. So this is what's talking to all of the 8 buttons that are here. There's actually 8 buttons. There's 5 in the joystick, 1 for up, down. There's up, down, left, right, and center for pushing, and then the 3 buttons down here. So they're all connected through I2C, and then they just connect back through the SCL and the SDA ports on your board and talk to it. So instead of using 8 pins for those 8 buttons, we're only using 2 wires because we're doing those through the I2C. So we have both I2C running and SPI running on this one. And finally, we have an Adafruit Tft Shield 18. This is a custom driver for this whole board. And what that does is it allows us to use it for this different screen. They've changed screens over the years, and depending on which screen you have, you got certain properties. So this is able to look a lot of that stuff up, and then you can make some settings custom to this display. Displays are a lot more work than what we've been working with in the past. So this is the reality of it. The next thing we need to do is we need to create the Seesaw object. So we need to create a way of talking on I²C. So we're going to do that. So I'm going to come down in here and I'm going to add that. I'm going to put that in here. And I've now created the communication for Seesaw, which is just SS. So it uses this information from here, which gives it all the pinout information. Normally we would have to give it the pins and tell it which pin is connected to SDA, which one's connected to SCL. It's all done already in this main file here because this is custom for the board. So it's already preset and it's going to have all those buttons available to you. So all those addresses are going to be in there, how we need them. The next thing we need to do is we actually need to communicate to the screen itself. For that, we have to create the SPI channel. So we're going to create the actual, we're actually going to create it as an object right now. So what we do here is I'm going to copy this because it's just easier. And I'm going to show you what's involved here. We're going to be still building this. So what we've done here is we've hooked all this up. So what we have here is we have the data, we have a data line, we have a CS line, and actually these two are the main lines. So this is for the SD card, because don't forget we have both an SD card, which also uses SPI, and the screen. So we actually have to separate which is which on here. And what I'm going to do is I'm going to move over here so we can see the rest of it here. So this will help us. We're defining SD, the CS channel. So that's the chip select channel, and that's connected to pin 4 on the Uno. So we can't use pin 4 for anything else. Pin 10 is connected to, when we trigger that, we'll send the data over that line for the chip. Actually, we'll just select that chip to tell it we're writing data to the screen. So this is how it tells the difference between the two SPI devices that are on board. One being the SD card and the other being the TFT screen. Then we have a data line and a reset line, and those are common to both of these. Now that's a specialty pin. It says -1. Just leave it. It's the defaults that it likes. And then it builds the TFT item. So again, it uses the TFT information screen, which is this one here. It's a 1735. The ST7735 is the driver for the TFT screen. So that's what we're using here, and we're using that to create the TFT device, and this is going to be found in that file, and we're going to be creating the pins. So we've created an object for the TFT screen. Now if I was using the SD drive, I would actually create an object now for the SD as well. I would have one here, SD equals Adafruit, and then instead of TFTCS, or yeah, it would be SDCS, but then the DC and the art reset would be the same as on the other one. So I would have to create another object to tell it how to address that, so I don't have to keep typing this over and over and over again. So that's basically what we've done there. So really, that's probably the biggest thing that we've had to do in there. The next things we need to do are going to be in the setup. So that's actually everything we need to do up in the top of the screen here. So just to recap that really quickly. Included all my helper files. So SPI is for communications. SD is to allow me to access the SD card. GFX allows me to use graphics for bitmaps on the screen. ST7735 is the actual driver for the actual TFT screen itself. Adafruit Seesaw.h, that is the communications on how to talk to the buttons that are on the shield. And then finally the last one is just the shield arrangement and how it works, and any special features it needs are all detailed in this driver. So it all makes sense, it just, there's a lot of them. Finally, we create the I²C object. So this is the Seesaw. And then we create down here, we assign the pins for the SPI communications, and we assign the TFT setup. So we're good to go. So now what we need to do is we need to put in whatever has to go in the void setup, whatever things we have to turn on. And there's a couple of things we want to turn on in here. So one of the things we want to turn on is we want to make sure we turn on everything for the SPI communications. So I'm going to copy that. I'm going to go down here and I'm going to go paste. And what it does, it starts by just disabling them. It sets them to high and low, all the different pins accordingly. Don't mind my phone there that you probably just heard beep in the background, because we're going to need it for one of the other displays later. So what we've done here is we've done the pin mode. We've assigned the pin mode here for the TFT display, and we set the output as high just so it doesn't do anything right now. And then we've done the same thing with the SD card and gone to high just so it doesn't do anything right now. So that's important. The next thing we need to be able to do in here is we need to be able to look at the Seesaw chip. Now there's a couple of things we can do in here. And one of them is going to be is we might actually want to start the serial monitor. So we can go down here and we're going to bring in the serial monitor. So I'm going to go copy and I'm going to paste that down in here. So I'm just going to start up the serial monitor. This will allow me to display any messages I want to use during the programming, which there are not very many this time. The next thing I actually want to look at is we're going to have to do some stuff with the Seesaw. So what we want to make sure is we want to make sure that the Seesaw has started correctly. So I'm going to copy that. I'm going to come down here. And let's have a look at what we've done here. So print the Seesaw stats. So basically what we've done here is I've told it to begin, the serial to begin, and it says while not serial. So it's actually waiting for the monitor to come on board. Once it's done, then it comes here because there was nothing in here. And then it says serial print Seesaw started. And it gives me the version and it gets me the serial number of what's there. Pretty simple, but that's what it does. The next thing we're going to do is we're going to start doing some things to the screen. So this is where it gets a little busy. There's a lot going on in here. So let me get to the end of this line so we can see what's going on, and let me paste that one in. Oops, that didn't work. I pasted in the same thing twice. Let's not paste that in again. There we go. We're going to copy this. And what we're going to do is we're going to start by turning the backlight off on this. Right now you can see a little bit of light. There's a little bit of light bleeding out. You can just see it up there at the top edge a little bit, actually. If I push the screen down, it tends to want to lift a little bit. I think the glue's just getting old. But there's a backlight. That's what we see through a TFT. A TFT has to have a light source behind it. So what I'm going to do is I'm going to start by just turning it off to make it black. And that's as simple as that. Next thing we do is we actually tell it to reset when we're starting back up. So we're going to come down here now. We're going to reset the screen so it looks normal. Once we've reset the screen, what we're going to do is we're going to initialize it. And what we're going to do for that is we're just going to turn it on. Now this is where some of that customization comes into it. And this is where it comes in really handy just to follow the examples to get what's going on here. So what we're going to do is we're going to initialize, and it's a 1.8 inch screen is what that is, measured on the diagonal. And it tells me what driver it is, it's TFT. And this is what's interesting, and this is something I had to learn myself when I first started doing this. So I use my TFT driver, I tell it to initiate, and it uses something in here. This is a keyword that's actually called black tab. And as if I realized what it was, I could have put in green tab because that's actually what it was. On a lot of these screens, if you've noticed, whenever you get a new screen, they always come with this little protective clear sheet that's on top of them. And what happens is you have to peel them off. Well, there's a color tab usually on the corner of it. Depending when this screen was made and the way it works, it has a little different colored tab on it. And this one was not black. It was actually green. And I believe it was green. It could have been red. But when I take it off, it actually set it up wrong the first time, and I had to figure it out. And it was something I only found out by reading it because I didn't find any good other documentation for it. So what we've done here is I've made it simple for you, is that we're going to use the default black tab and then we're going to fix it. And I'm going to show you how. Because it really only made one error when I was doing it. So the next thing I'm going to do is I'm going to fill the screen with color. Because I want to be able to test it now. So I'm going to come down here and I'm going to fill it with color, and I'm filling it with the color cyan. Again, these are pre-built colors that are available to me. You can actually go back in. This is in the ST77XX cyan folder. If you actually come up here and you go into the ST7735.h, it refers to another one that it loaded in automatically for you. And you'll find an ST77XX file, and in there you can actually change the colors. You can actually go in and create your own custom colors. You can add to it. So that's just something, but that's beyond what we're doing today. So once I've done that, what we're going to do is I'm going to come down here and I'm going to turn my backlight back on. So what I need to do here is I need to turn it on. Now remember I turned it off earlier? I set backlight off. I could probably get away with doing the simple, but I'm going to leave the one that they put in the code just to show you how complicated it can get. This is what they did here. So what they said, for, and they created an object called I. So they did it in here rather than putting it up in the top and declaring it. TFT Shield backlight off, and it says if off, turn on, and it says to bring it up in variable states of plus 100 at a time. So what it does, it actually fades on rather than just bang, it's on. So you can actually do that, and then it says set backlight to I. And by putting in I instead of telling it up here where we just told it to turn off, we could just tell it to turn on. This one actually gives it a value, and it keeps ramping up until it gets to full value. And what that value is, I'm not sure because I never bothered to print it. I guess I could have. And then it does a delay of there one in between. You could slow it down and bring it up gradually. So this allows you to play around with it a little bit, and you can fade it on instead of having it slam in your face on. So just something that you can do with it. Just something a little different than the norm. So just keep that in mind. And then what I've done is I've gone ahead and I've told it to change color a number of times. And I'll just grab all of these because I wanted to cycle through some colors. So once it's finished bringing up the screen on brightness, it starts with cyan, and then it goes to red to green to blue to black. So finally it goes to black, which looks like it's off. So if I have that in there, that's what's going to happen. Now we have one little last piece we have to set properly. Actually, just one little more block of code in the setup. So this is a fairly long file. You can see why I'm not typing it today. This would have taken quite a while. And we only have so much time. So what I'm going to do in here, let's see, where am I here? Oh, yes, okay. So what I'm going to do here is I'm going to bring this in, I'm going to copy in another section of code, and I'm going to explain it. It's going to be the easiest way for me to do it. So I'm going to talk about the rotation here. What I found with my tab at the top here, set to black tab, that I talked about earlier, and I found out there's actually a green tab, a red tab version as well. What I found out was that the reason they have the different tabs on them, and what it tells me the rotation of the screen. And what that's referring to is, where is pixel 00? So it's columns and rows, or columns and rows. So what we have is we have a 160 by 128 screen. what I've done here, by default, for a black tab, it actually measures this bottom corner as the default. So if I were to take this same screen and put it onto a vertical mount, in other words, I made it look like a sheet of paper style, it would be 160 across, it'd be 128 across by 160 down. This is the other way around. So what I wanted to do is, it was printing all in the wrong way. This little bit of text here actually showed up across this edge, which was not very handy for what I was doing. So what I had to do is I had to rotate the screen. So for set to black tab, the rotation default is 0, which is set up for 128 by 160 high. If when the rotation is 1, the screen is 160 wide, which is what I have now, by 128 high. So that's what I needed to do in here. So I set my rotation to 1. I also set my text size to 1. I set the text color to white. Again, that's those predefined colors, so I can use any of those I want. I placed my cursor in position 0, 0 up here in the top left, and I printed this that says press all the buttons, and it says print the text. So that's exactly what that did, and it printed it right there. So if I press reset, we're going to see that the screen is off. It's going to turn on. There's the cyan, red, and it goes through the others very quickly, and it comes up with press all the buttons. So it turned on and did its thing. So that's what happened in there. So now, what we're going to do is we're going to create a variable, because I added one in here that was not in the program, but I thought it needed it. So I'm going to create myself one little bit here. And actually, I did it after the setup, which doesn't matter. It can happen in either place, as long as it does it before it goes into the void. I've created a variable. So I created one variable called button history, and what was happening was it used to be down here. I moved it. I didn't like where it was. And what I've done with button history is I've created it as a 0 value just for a starting point. So the button history. And I'll explain what that's for when we write the program for the code. So that's what we've done in the setup. The setup was quite long, so let's just review it really quick. First of all, I start by turning both of the SD card and the TFT to the off position for communications. I turn on my serial begin so that I can start seeing some information here, and it is printing up information that tells me that the Seesaw started, tells me the version, gives me the number, sets the backlight off, resets the screen, sets it to black tab, which I find out later that is not right, and then it says TFT OK, so it actually communicated to it. Once it gets down there, I set it to a solid color. I fade on the backlight. Then I cycle through the various colors. And once I get through that, because that's just a block screen, so that doesn't matter. So what happens after that is I change the rotation to the rotation that I want to read it as a wide screen instead of a tall screen. I'm going to change the text size. I'm going to change the text color. I'm going to set the cursor to the home position. In other words, position 0, 0 up here in the top left. Press in, press all the buttons. And then last, I'm going to set this thing called button history, and I'm going to set it to a value of 0. Whew! There was a lot of stuff there, but we got through it. But that's all, that's taken from the examples, and then I made some changes to it because I wanted it to run a little different than the default examples were. So now the next part is actually pretty simple. So in the main loop here, we're going to replace the first part of it with a very simple section in here. And I'm going to come down here to my main loop. I'm going to copy this over. I don't need to keep that. And all I'm doing is here, I'm going to read in the buttons. And that's really all I'm doing. I'm creating a tag here called buttons. And it's going to equal seesaw.readButtons. Because that's what it's defined as in the Seesaw. And that's in that Seesaw folder when we did our helper file. And then what we're going to do is I'm going to set the text size to 2. Now, up here for printing out this original line of text, that was text size of 1. That's pretty small. I want a little bit bigger text, so I'm going to increase the size to size of 2. So that's what I'm going to start with. And then what I'm going to do is I'm going to do this. And this is how I'm going to read the buttons. So when I come down in here, let me bring that down here. If, and it says not buttons, and it says TFT button down. So what I'm looking for is, I'm looking for the down button. And the down button is off of this joystick. So that's when I pull it down. And what's going to happen here is when I set the text color, I'm going to set the text color to red. I'm going to put the cursor at 5860, which means come across 58 spots, go down 60 spots. Then I'm going to print the word down. And I'm also going to add, remember button history, we started with 0 here. I'm going to add the value of 1 to it. So now instead of being 0, it's going to be a 1. So let me pull that down. And on my screen, I get the word down roughly in that middle of the screen. So it's 58 across and 60 down. And where that starts is the top left-hand corner of that word. So that pretty much centers that word on my page. That's what I did there. So I actually got it pretty close to the center of the working area that I have. So that's what I wanted to do. So after we do that, and we're missing one spot in here, and it'll give me a hard time if I don't put this in. So let me just get my brace up there to match that brace. So it's open and closing of an if statement. So what we have down here next is we're going to put in another if statement. So let me grab everything for that one, and then I'll grab the whole bunch after I do this next one. So here I'm actually saying, hey, another if statement looks just like this one, except instead of down, I'm going to go for the left button this time, which means I'm going to push the joystick to the left. I'm going to start at column 0, but row 35. I'm going to put in the word left, but I'm going to do it in yellow. And then I'm going to add 2 to the history. By adding 2, history was equal to 1. Now it'll be equal to 3. It's the addition of those. So this is sum equals, is what this bar means. And that bar, if you're looking for it, is the one above the enter key on the right-hand side of your keyboard, if you have a standard keyboard. So let me push left, and there it shows up. Left shows up in yellow on my screen in that particular area. So that's what that does. So now let's go all the way down here, and in fact I'm going to grab everything to this point. I'm going to copy a lot because this would be a lot of typing if I didn't copy it. So I'm going to come down here, go down to my next spot, and I just put in a whole bunch of stuff here. What I've done is I'm just doing the same code over and over again with customizing it. So in this case here, I'm doing button up instead of button down. And instead of button left, I'm going to make it green. So if we go button up, green, and we're going to set the cursor to column 70, position row 10, which is pretty high up. I'm going to go up. And if I push it up, there it is in green. It put it on my display. And it adds 4 to the column, which was 3 plus 4 is now 7. Okay, next thing I'm going to go for is I'm going to go for right in blue, column 100, row 35. And there it is in blue. And I'm going to add 8 to my 7, which now makes it 15. Anybody who's familiar with programming will recognize that these are key numbers in binary. These actually convert to values of binary numbered positions for where the bits are located within a word. Next one is I'm going to go orange, and I'm going to do that one for the button number 1. So I press the 1, and that actually comes out in orange and adds 16. The next one is going to come out in white, and I'm going to add 32 for the next button. The third button is going to be 64, and I'm going to add 64, but it's going to come out in cyan, and it does. So I've actually got all of those came out just fine. And then there's one more, and this is the button in. So this is the big button here on the center position. And that one's going to come out in magenta, and it's going to write the word select, and it's actually going to put it down here to the right of this stuff here, down to the right of number 3. So it's going to put it down here and over towards the right-hand side, and that's my center button. So, and it's going to add 128 to it. But before I do that, I want to show you what's going to happen next in the code, and the best way for me to do that is to put in that block of code and then show it to you. And this one's going to go all the way to here. It's a big block of code because there's quite a few things that are about to happen. And here we go. We're going to paste that in. And this is a big block of code. So what's going to happen is when I press select, it's going to add 128 to the total. My total is going to be equal to 255. In hexadecimal, this value here, 255, is equal to FF. So it says here, if button history is now equal to FF, so I'm using the double equal sign to compare. What I'm going to do is I'm going to pause for 1 second. Then I'm going to invert the display. So I'm going to change it from a black background to a white background. Now, if I did that without doing anything else, my white number, number 2, would not show up. What it's going to do, it's going to change all the colors, so the ones that are dark here will become light on the other version. But it's going to invert it, so it actually reverses all my colors on me. And then it's going to turn it off and turn it back to this view with the black background. Then it's going to take my button history and I'm going to make it back equal to 0 again. Then I'm going to set my text color to green. And then this little block here is I'm going to create text sizes. And I'm going to start with a number 1. And I'm going to show you it in text size 1. And then it's going to go to number 2 and text size 2, number 3 and text size 3. All the way up until it gets to 9. At 9, it's going to show you what a number 9 looks like, except it's going to be in size 9 text. So there's multiple sizes available. And then again, what it does, it just puts it in starting at row 10, column 10, row 40, and it prints the value and delays for 1 second in between. When it's finished that, it sets the screen and fills it with black. Sets the text size back to 1, because we're going to be at text size 9 by this point. So it's going to set it back to text size 1. It's going to set the text color back to white. It's going to go back to the home position, and it's going to type that little line again. Press all the buttons. It's going to put that in at the top again. So here we go. So when I press down on the center, and now we see the text sizes rolling up through the screen. And there's 5, 6, 7, 8, and there's size 9 text. You can probably do size 10. In fact, if you're very careful and you don't get too wide, you can probably get up to about size 14 before you run off the screen and you're too big for the screen. So that's basically what that does for us here. Now I did talk about changing these 1, 2, 3, 4 just to show that I can do it. I'm going to go A, B, and C. Let me validate my code because I may have missed something, and it's possible when I copied and paste. It takes a bit to do it. It's a big program now, and this is one of the disadvantages of Arduino, is the fact that it's slow when it's doing this. But it should work. So I just want to make sure the first time through it's going to take a bit. It's got a lot of checking to do. There are 170 lines or so of code in here. It says it's done compiling. It was happy. What I'm going to do is I'm going to upload there. So let me make sure that I am connected to my Arduino Uno. I am. So now that I am, I'm going to upload it. So this screen's going to update shortly. We're going to see that happen. The uploading is taking place right now. And in a moment, it should say it's done. It is done uploading. And now this should go through a boot up cycle. And we should see it go through our colors at some point, if I did it right. Did I do it right? Uh-oh. I probably missed something important. I bet you I did, because it should be working better than that. So I obviously missed something in there. Let me do something really quick and easy. I may have missed one little line of code, which, hey, is possible. These things happen. So I'm going to do a copy here. Yeah, I'm short a couple lines. I probably forgot one little block of code. What I'm doing is I'm actually pasting over it with the code that I know that works. Yeah, I'm longer here. So I did miss something somewhere, which is quite easy. So I'm going to take this one, and I'm going to take the 1, 2, 3, and I'm going to make it A, B, and let's make that one C. And I'll go ahead and just upload that. That one should work fine. So it says it's compiling it. It's now uploading. We're going to let it upload. It says that down in the bottom left-hand edge of the Arduino page, right down here. It's done uploading. And here we go. Look at that. It fixed it all up. Now, I can go up, down, left, right. Doesn't matter what order I do these in. A, B, and C, like I said I'd change them to. We'll hit select, and then when it does, it goes through, and it will reset it all, and it'll be ready to go again with another choice. So it does work. I missed something when I was copying it over. The full length of the code here, if you really want it, just let me know, and I would gladly send that to you. But it works. And like I said, I can do these in any order that I want. It doesn't matter. When it adds up to 255 by having all 8 buttons been pressed, then it goes through this routine at the end and resets it and gets ready for doing another set of numbers. So it did work. I probably missed something when I was scrolling through the screen. It's easy to do, as you can see. This is a fairly long program. It was 162 rungs. Pretty long for a show of this size. And I wanted to show you that, and I do want to show you some of the other features of some of the other boards. So that's how the Arduino works, though. So what we're going to do is we're going to be working with some of the other things that are here now. So let me move that one out of the way. And I got to make room here. And we're going to bring this one into the screen here. So this is one called the Clue. This is a fairly new board from Adafruit. This came out this past year. And what it's doing here, and let me turn off this screen and turn on my Muse screen. This is what's connected to it. So this one here is showing me a display. Now this board is pretty unique. It's a smaller board. There's that red tab I was talking about. So how they come with a protective screen. I haven't peeled the screen cover off this one yet. That one's got a red tab on there, so I may have to keep mind of that. It might be important to me later. So that's always important to know. Okay, so let me just move this on up to here. And what we have going on here is we also have 2 buttons on the front of this. We have a whole bunch of connection pads across the bottom that can be used. And on the back, this thing is packed full of electronics. In fact, there's a temperature and pressure sensor over here. There's a humidity sensor in here, gyroscope and accelerometer. And when we look at the back here, there's also the TFT. This is a 1.3-inch TFT, a little bit smaller than the one we used the last one. It's got a microphone built into it. Let's see, it's got a reset button, of course. It's got a stemma connector. It's even got some wireless. This is Bluefruit. This is Bluetooth here. They refer to it as Bluefruit. It's an NRF 52840 communications chip up here in the corner. So that's available to us. It's got a battery connection up here in the corner. And it also has a speaker connection way down here on this side. So we can hook up all kinds of devices to this and make it do all kinds of weird and wonderful things. this is what I have on here. I have a little bit of a demo running for temperature and humidity, and I'll show you what I've done here. So here's the screen here. At the top, this is the clue test by me. The original example sources I used from Arduino, or from Adafruit, I should say, and then converted it. This is running on CircuitPython 5.3.1, the newest stable version of at this point. I only have one helper file to bring in this time. So unlike we just saw in the other one, I actually have to bring one helper file in here, and that is Adafruit clue, import clue, which includes how to access all these devices that are built into the board. So then what I have is I have some temperature ranges. So I have Celsius and Fahrenheit. I'm actually displaying both on the screen here, Celsius and Fahrenheit. And those are a little bit high. I know they are. I don't think it's really that warm, although there is some heat coming off the chip. And I am on an insulated pad here, so I may be getting some much higher readings than I should be. But we're going to test that. Then what we have in here is we have a humidity range that I have in percentage. And then what I have here is set to true to enable audio alarm. And I have that set to false because there's a little speaker on the back. And I don't want that beeping while I'm displaying stuff here right now, because it would be beeping because something's in the red. So I've turned that off. And then I've got my text here. And my text basically just says here, clue simple text display. And I've set the scale of the text to 3 on here. And then I've actually set it for display. The first line of display, I want to put in the word temperature, and for my second line, I want to put in the word humidity. So these are predefined so they don't overlap with each other. I could get into it and I could do it without the presets, and I could actually draw it just like I did in the last one. Set my cursor position, set my text sizes, and all that other stuff. And then here's my loop. So there's no other setup needed for this one. The rest of the loop is here. This is much, much shorter than the last program. What I'm saying here is reset alarm on each loop. Basically, I'm taking the alarm and I'm setting it to false. So if it gets turned on again, it'll be because it sees something happening within this part of the code. But it gives it a chance to self-reset. And it says read the sensors and create the display variables. So first thing it does is I'm going to read the temperature in Celsius, which is its default. So I'm going to read the clue temperature. And then I'm going to take it and I'm going to do the math to it. I'm going to multiply it by 9, divide by 5, add 32. And that changes it from, I guess I can get rid of this other line of text here. I don't need it anymore. Basically, this one here, if I do that, it converts it to Fahrenheit. So I have a temperature C and a temperature F. And then humidity just reads directly off the chip. Then what I'm doing here is I'm creating my prints for the screen. So lines 3, 4, and 5. So we had 0 and 1. If you noticed, I skipped line 2 and there's an empty spot there. There's a blank space across the screen, so I could actually add more text. So I have spots 3, 4, and 5. And what I've done in here is clue display. What I've said here is take the temperature, colon, and then I'm going to say format it to 1 decimal place. Give me a number to 1 decimal place. And then add the letter F. So what we would normally do in Arduino, temp, colon, space would be on 1 line of serial print. The second line would be temperature F. And then the third line would be putting in the F, the space and the F, and then return so we can go to a new line. Here I can do it much simpler. So I just have to put in the fancy code here in the middle that tells it to look up what's at the end. So there's my temperature Fahrenheit, temperature Celsius, and humidity. So that's what I've done here is I've created all these custom labels with the text in between, everything to 1 decimal point. And then it says here, set the color of the text based on the value. In other words, if it's below the minimum, make it blue. If it's above the maximum, make it red. And if it's in between, make it white. Like the humidity is in the OK range right now. It's not low and it's not high. And I've done that for each of the 3 parts. Then, finally what I do is I add in this one line down here called clue display.show, which says, okay, now update the screen. Now that I've set everything up, send all the information out at once and update the screen so that it doesn't do it constantly as I'm reading through each part, so you don't see flickers of colors on each of the lines. And then I have my audible alarm if the alarm is on, which I set to false. it would ring the alarm at 2000 hertz, at 2000 hertz basically, and then it would stop tone. If there is no alarm, it says stop the tone. And that's basically what it does. Now let me show you those numbers changing, because I know that value is high. I hope I don't short anything out here. I'm going to get my block of ice and my plastic bag. Here we go, a block of ice. We're going to sit that on there, and we're going to see if we can get it on the... We can see already my humidity has changed to blue. Oh, look at my temperatures are... There they go. Oh, one's starting to drop. They're dropping. I'm probably not quite on the sensor. I'm trying to see where that sensor is. Oh, sensor's way over on that side. There we go. Look at that. I'm close to being on the ice anyways now. And you can see they've changed to blue. They've gone to cold. And you can see they're dropping quite rapidly. So as I did put something cold behind them, and they did read, I lifted off of there. We can see the open air is getting at it, at the sensor, and they're adjusting on their way up. They are currently blue in color. Let's see if it goes white. Oh, there goes one of them's gone white. So we can see the three different colors I have here. That's actually red. That's what happens when you're looking at lit screens on lit screens. But we can see that they do change. And I can get my block of ice out of here with the sweat of the bag on it before I short out the electronics. But I just wanted to have something cool there. And we can see those numbers are changing accordingly. So that's what that happens there. So that actually works pretty good. And that's the whole code. Now I showed you that one in that step here because what I'm going to do, and I'm actually going to be changing boards here. Because I actually want to show you some stuff here. So first of all, what I'm going to do is I'm going to pop out to my main camera. So there you go there. You can see it here. If you want to see the back of that again, we can see all the different labels on there. There's a ton of things on this thing. Yeah, there's a magnetometer there, so that's there too, so it can read north, south, east, west. It can actually tell where it is position-wise. Lots of different things on this. So it's just smack dab loaded with stuff on here. So let me just, while I'm doing this here, I'm going to turn this one off so I can unplug it, and that's fine. If I unplug this, in fact, what I'm going to do is just take that, move that out of the way, and I want to show you another one, and I'm going to plug it in. And I'm going to pull it up on the screen before I turn it on. So just let me do that. Let me get it centered here on the screen. And I'm going to do this because I want to show you some code, and then I'm going to show you the last three displays actually, but I'm not going to load up any code for them. I'm going to turn this on. This is a name badge. So I actually have, it says microcontrollers with kingernorth. And you may have heard that as well. It actually plays a little bit of a tune. There's a speaker on the back. And this is a name badge. It's actually got holes up here you can hook up a lanyard to. I also have a plastic case that it goes on and has the lanyard attached to it. But I can press buttons on here. So I can throw up a barcode. That barcode is then used to read in it. If you read that with a phone app or something, it'll come up and actually show it as my YouTube address. There's my Twitter address there. If I go back to the beginning, it puts it back to microcontrollers with kingernorth. So it's like a name badge. I also have the ability here, if somebody gives me, I teach classes, so if somebody gives me a wrong answer, I can give them the red lights. If they give me the right answer, I can give them green lights across the bottom. And if it's a razzle-dazzle type moment, I can do this, and it'll create variable lights with variable items. So what I'm going to do here is I'm going to load up this code. And it says it already exists, but it doesn't. I'm going to go open. Code, open. So now let me go on to my main page. It's going to go through that again. But here's the new code. So let me explain what's going on in here. So in here, this is PyBadger. This is written in CircuitPython as well. And again, what I've done here is this is the helper file. So it's import Adafruit PyBadger, import PyBadger. So it does that. And I also bring in time and random because I want to use those features in here. And then what I do is I set my my pixels brightness. So that's the across the bottom here. These are neopixels. So I'm actually setting the brightness of those down to just 0.2. And it says here, create some colors, some default colors that I want to use in this file. So I've gone in here and I've created white off, which is basically black, red, blue, green, and yellow. And then what I've done is I've created these. These are what they call tuples when they're inside of round brackets like that. These are related numbers that work as a set. And then what I've done in here is I've created a list of the colors, white, red, blue, yellow, and green. So it's going to take this tuple and put it in here under the name of white. So by putting a group of tuples together, I've created a list. And this is separated with square brackets. So what this does is it allows me to call these things when I want them. And I can call colors. And then I can now have an array here called colors. This is position 0, position 1, position 2, position 3, position 4. So position 0 of colors is equal to white. Position 1 of colors is equal to red, and so on. So I've actually taken an individual detailed list, combined them into a bigger group. Really handy. Now I've created some subroutines, and I've created subroutines for that countdown at the beginning with the blue lights. So I started out with all blue fill, and then I subtracted 1 from the count, and I went down until I got down to 0, and basically when I got to the end of that, countdown was done. Sparkler, here's that one where I random number, and I actually pick a range from 0 to 5, which is actually 0 to 4 because it's starting at 0 but less than 5, and intercrypt by 1. So what I do is I pick a number. The number is the neopixel number. It goes from 0, 1, 2, 3, and 4 for the neopixels. And the colors are also from 0 to 4. So I pick a random color from that colors list that I created. And then what I do is I display them on here. I have my wrong, which fills them into red. I have my correct, which fills them into green. And I have my name badge with the control, in here, with the information says microcontrollers with kingernorth. So I've actually created all that. I've created the scale size of text. And if you notice, kingernorth is bigger than the other 2 lines of text. But I've done that. And then I just call the routines to run through during the startup. So there's my badge. I go through the countdown, bring down the blue lights down to 0, and then I play the file called rimshot, which is like somebody hitting the edge of a cymbal. And then here's the whole program after that. So I have in here is I have a auto dim. Right now that display is dim. If I shake it, it goes bright, which is actually harder to see. But once it dims, it'll go back down a bit, and we'll let it drop. It will drop again. We'll just let it go. And then we have here, if button A is pressed, show the business card. The business card is my Twitter logo and the word @kingernorth. So I've added those in there. So that is this button here, I think. There it is there. There's my Twitter logo with @kingernorth. So that's what that button A does. If I push button B, which is right there, it goes to the QR code. This has a QR generator built into it as part of the default on the PyBadger. So I put in the address youtube.com/kingernorth, and it created the QR code to show with that. And then I have the start button, which is this one up here. that brings me back to my badge, which is up there at the top and created. The sparkler is the select button. And then I have the down button for wrong and the up button for correct. And I've just created those, but that's a nice little shorter, much shorter program. Very effective badge, gets the people's interest, especially when you're trying to teach kids some basic programming. They like it because it's unique. And badges are getting common, electronic badges at some of these electronic shows. So here's one where you can customize it yourself and change it over. So that's the Pi Badger. So let me move that one out of the way to show you the last three. There's things like this. So as I move that around, in fact, I'm not sure if I block some of that light, you can see as I'm tilting it, it's actually taking a level because it's got an accelerometer in it. It knows when it's level, the movement, the X, Y, Z axes. It's got that point of difference axes, and there's an eyeball moving around inside of an eye. So the iris moves around in the middle. So there's just one of those things, and you can have it. And the idea is that you could shake it, and the eye bounces around, and it moves. And there you go there. You get the idea. In fact, you know what? Let's take this out to the big camera. We don't need to see the code for this. And this was a custom one that Adafruit did at one point for Halloween. If you can see, it's actually like a skull. And I just have it hooked up with a LiPo battery here. Again, on the back, there's all kinds of parts. There's a spot you can plug in that feather wing, that M4 that we used before. It's got all kinds of connectors to connect things to. It's got the different chips. It's got a few built-in features as well. And some touchpads down here. Okay, so that's that one. The next one, I think you'll like. This one here. This is what a TFT screen, but this is attached to, on the back side, is a Circuit Playground Bluefruit. So this one actually has that little logo there you might recognize. That little logo right there is the Bluetooth logo. So this one is a Circuit Playground Express. There it is there. Lots of features on it. It's got NeoPixels. It's got all kinds of stuff. But I'm using it for the wireless communications. Because there's a picture. Now what I'm going to do here is I'm going to go and I'm using an app on my phone. So I actually have a phone. I have an app here. And what I'm going to do is I'm going to choose an image. You can't see this part, but I'm going to grab one here from somewhere. What do we got? Here's one with a bunch of boards I had put together. And I'll send that image, and I can send that on there. So there's from my phone. There's the image right there. And I sent it. So let's do one more. I'm going to take a picture of this. So here I'm going to... what am I going to do here? That causes it to rotate. I'm going to take a photo here, and I'm going to move right down here, and I'm going to go use that photo. What this app allows me to do is move that photo into there. I'm going to put that into there. I'm going to click the done down in the bottom. And now what I'm going to do, very quickly, I'm just going to move this up here so you can see it. I'm going to hit send image. And wirelessly, it sends it to the other board. So it's actually pretty neat what you can do with that. So I can actually send live images to it. And you could do this for any number of things. It could be Christmas decorations. You can get a little glow ball. You can get it to mount that in and hang it on a tree. Again, this is running off a battery. There's a battery inside here. That's what this little cable at the bottom is for. That red and black wire connected to a battery that's sitting in between the two halves. And all I do is unplug it when I'm not using it. I can also change images by, if I loaded a bunch of images and then use the buttons in the back. But I have it set up right now to be connected through Bluetooth. So it's actually connected through my phone. So I can take pictures and put them up there. And as you saw, we took the picture and put it up there. The last one I want to show you is this one. This is really unique. This is called an e-ink display. This is a picture I actually loaded onto here. I created this picture in my just in Microsoft Paint. Nothing fancy. I created it 240 by 240 pixels. I have here, or whatever size, yeah, I think it was 240 by 240. This is just a Circuit Playground Express, a regular board. I had it plugged in, and I loaded that image into it. I loaded that image last Saturday. We looked down inside carefully. There's no battery in this thing. This is not connected to anything. And this is the difference with e-ink. One of the big differences is, well, there's many differences, but one of the differences is the fact it's not full color like TFT. TFT, I have full range of colors, basically. This thing here, like I have at least 64,000 colors with TFT. With this, I either have 2 or 3 depending on what it is. This one's considered to be 3. I have black ink, I have red ink, and I have a white background. That's it. That's all I can choose. So I can make it black, red, and white, my image, whatever image I created. It is a lower resolution. It actually is a much lower resolution than the TFT. But there's no power connected to this. So I could actually use this as a name badge, an e-ink, set it in the morning. I could put my schedule on it. I could do whatever I want on it and then walk away and it stays on there. If anybody ever had one of those Kobo readers that used to be out, the ones that you read in daylight without, because there's no backlight on this, it works, is that you can, and it's very readable in daylight, you can actually use this and have information on it. And it'll display and display. This has been displaying for almost a week now without any updates and no battery connected to it any time during that. In fact, I could unscrew this board from it and walk around with just this first part. So all I have is just the display, and that image will stay on there for quite a long time. So that's what e-ink does for me. So e-ink allows me to do that. So the downsides of e-ink is I only have limited number of colors, and it's very slow at updating. And because it's that, you cannot constantly update it to it like a TFT screen. You can't play a movie on here. You can display images. I can actually use that same app I used to send an image to my TFT screen. I can send one to this. I can send an image here and it will redefine it for e-ink in the proper color, so it gives me shades. So it does it all with the little dots. But the problem I have is that it's going to be not quite as sharp as color. But once I've had it in here, I don't have to power it up or keep it powered. The other thing with this here is if you are going to update these, they recommend about every 3 minutes to update it if you want to keep changing it. If you're not looking at changing it, then don't update it. But don't try to expect to do it and then 10 seconds from now do it again. It actually takes anywhere, depending on the screen, anywhere from 5 to 15 or so seconds to update the screen when you send an image to it. It actually looks like it's writing it in waves until it's completed. So that's what that does for e-ink. So e-ink, though, is extremely low power because there is no power going to it. It remembers. So that's where e-ink is a huge, huge advantage. Where it's a disadvantage is the lack of color choices and the fact that you can't keep updating it live. You have to wait. You have to pause in between. E-inks are not happy about being updated constantly. So there you go. There's a review of TFT and e-ink displays. And in fact, actually, let's just zoom out. And we can see here, there's our other and our Arduino. So we had a bunch of different displays. Pi badge is still sitting over here off to the side. So you can see here we had a whole bunch of displays today. I think we had some interesting times playing around with these. We created a few different circuits. You can see there's a lot of programming involved in these. Displays are not for the faint of heart when you get past the OLED and the LCDs that we've done in the previous ones. but you can do so much more with these. These ones here have a lot more capability to them. So have a look at them, but be patient when you're working with them. You'll get through it. It just takes a little bit longer, and it definitely takes more code to write these up. So I hope you have enjoyed this today. This has been Microcontrollers with kingernorth, episode 17, TFT and e-ink displays with CircuitPython and Arduino. And I'd like to thank you for watching this video. Please add your comments anytime. If you like this video, please give me a thumbs up. Also, you can subscribe to my channel at any time. You'll get notices when shows are going live. And I try to do these once a week. So far, I've been managing to do that with this series of shows. So you can catch me here at youtube.com/kingernorth. Please subscribe. That lets me know. I've been getting a few subscribers, and it's nice to see those people out there, and people are actually looking at some of my topics. You can also get notices on Twitter. My handle on Twitter is @kingernorth. So just look that up, and by all means, follow. And until next time, next week we'll be back, hopefully with episode 18. I'm not sure what I'm doing at this point. I might change it up a little bit on what I've been doing, but enjoy yourself. Have yourself a great weekend. It's a nice weekend here where I am. Hopefully it is where you are as well. Stay safe, and until next time, keep programming and having fun. Thank you.